You can see it sensing things and turning. So there's a few things to optimise, like how far before an object it sees does it turn, how long it turns for. It obviously has no knowledge of where it's been, so it's kind of haphazard as to how it gets out of the maze.
This is my obstacle avoiding robot I built. Let me show you how it works.
So let me walk you through it. The base is just hardboard. I chose this because it's sort of cheap and easy to work with. The back is the wheel here. This is just a caster, so I didn't have to work with complicated steering. And these are just servo motors to drive the wheels, and this is another gaffer tape just to hold wires in place. On the power is a USB power bank, just what you would get in, just what you would charge your phone with. On the front there are 3 ultrasonic sound sensors. The way these work is they have 2 silver barrels. One is a speaker, one is a microphone. The speaker sends out ultrasonic sound and the microphone listens for that back. So how it works, you send the sound out with the speaker and you time how long it takes for the microphone to hear that sound bouncing off objects and coming back. So you take that time, divide it by the speed of sound, and that gives you the distance that the sound has travelled. And then you divide it by 2 because the sound has to get there and come back, and then that gives you the distance of an object away, gives you the distance an object is from the robot. And then you use that to steer the robot. The brains of the robot is this Arduino here. Can't really see it well, but there you go. And the way this works is this has many inputs on it, and ground and power, digital and analog inputs, and you can plug in different components. And then you write the code in computer, upload the code to the Arduino, and it will work. The basics of the code are that there's a setup function which runs once as soon as you power it on, and then a loop function which just continuously runs. The way the algorithm works is it will continually be going forwards until any one of these sensors detects an object within a given range. I think I've picked like 5 or 7 centimeters, something like that. So if either of the side ones detects an object below that distance, it will stop the wheel on the opposing side until the distance is large again. So for example, if something gets detected in this side, it will stop this wheel will continue running, and it will turn until it's clear. Similarly with this one, if there's an object was here, this wheel was stopped, turning this one to turn it away. If something was detected in the front, it will reverse for a bit and turn towards the direction with the biggest distance measured by the sensors. So for example, it will go back, and if it's measuring, like if there's something here, this one measuring 2, and this one's measuring something like 50, it will turn towards the 50 and hopefully towards an open space. And then similarly, if it was to reverse and was detecting something here, it will turn this way away. So that's how the front sensor works. I thought I'd set up the maze course that I've been using to optimize this algorithm and show it working. Okay, so here's the little course that I've got set up with some storage boxes, things I can find around the house. Let's turn it on and watch it run. So you can see it sensing things and turning. So there's a few things to optimize, like how far before an object it sees does it turn, how long it turns for. It obviously has no knowledge of where it's been, so it's kind of haphazard as to how it gets out of the maze, but hopefully it'll get there. Turn back. But as you see, it works quite well. Usually it comes out well. There we go. out of the maze, and free! Hope you enjoyed my video.